Hello, I am Dr. Levon Hairapetian, a business professor at Houston Baptist University. In this short video, I will show you how to calculate Euclidean distance between any two observations. Let me switch to PowerPoint. Euclidean distance is the most commonly used method of measuring similarity or dissimilarity between two observations if the observations contain variables with numerical variables only. For example, if I have two observations U and V, each of them contains Q variables like U1, U2 up to UQ, V1, V2, and VQ. And the question is how to calculate Euclidean distance between U and V. This is the formula to calculate Euclidean distance between U and V. So the way we do it, we see U1 minus V1 squared, that's this, plus U2 minus V2 squared, plus, and we do the same for all corresponding variables. Last one will be UQ minus VQ squared. And then we take square root of that sum. That square root will be Euclidean distance between those two observations, which is the same as measure of similarity or dissimilarity between those observations, depending how you will interpret it. Now let's discuss this in example when we have three observations. So my observations are information about three people. Sam Thompson, Nancy Green, and Tanya Simpson. For each observation, we have three variables: age, annual salary, and credit card debt. So now I want to calculate Euclidean distances between Sam and Nancy, between Sam and Tanya, and between Nancy and Tanya. And in order to do that, we will use the formula which we just discussed. So I will switch to Excel and we'll demonstrate how to calculate these Euclidean distances. Well, this is the same information which you just saw on the slide. Now let's calculate between Sam and Nancy, which means between these two observations, it will be equals square root SQRT. So what I'm doing, I'm implementing this formula when the role of U1 is related, the age, and U2 is annual salary, and U3 is credit card. So U1 is for first observation, like in this case for Sam, and V1, V2, and V3 are for the second, for Nancy. So it will be, I'm implementing this formula, square root of this minus this squared plus this minus this squared plus, and for the last variable will be this minus this squared, and close parentheses. So this is implementation of this formula when we have three variables. And so the distance is this number. Now I will do the same and calculate Euclidean distance between Nancy and Tanya, which means between these two pairs. So now this will be my variables U1, U2, U3. This will be V1, V2, V3 equals square root for Nancy minus age of Tanya squared plus squared and plus for the last variable will be this minus this squared and close square root. And when you see this, that means the number is large and the width of the column is not large enough to show the number. So this is what was the situation. You can just increase the width by double clicking here. Now, finally, let's calculate Euclidean distance between Tom and Nancy, which means this will be between this and this row. So it will be square root again. Difference between ages squared plus difference between salaries squared plus difference between credit card debts. Squared. So what we did is we calculated Euclidean distances between all possible pairs in our 3 observations. So this concludes my short video, and let me stop the sharing. So see you during the next video tutorial.